So we're looking at Beer-Lambert'S law. Beer-Lambert'S law. Now, in Beer-Lambert'S law, those are the two laws of absorption of light. Beer-Lambert'S law is actually a combination of two laws, Beer's law and what? Lambert's law. So we're going to take them part by part before we combine them together. Now, Beer's law states that the absorbance of a light absorbing material is directly proportional to the what? The concentration of the light absorbing material, right? Or you say the absorbance is directly proportional to the number of molecules in that light absorbing material. So what that actually means is this. Now, if you have something like this, if you have one solution here, this solution, the concentration is 10 molar. And you have another concentration here, another solution, the concentration is 5 molar. Which one do you think will absorb light more if you pass light through it? The 10 molar, right? Because this one have more particles that can absorb light compared to this one, right? So Beer's law states that if light is passing through this, if you have an incident light passing through this light absorbing material, that the light absorbed, the absorbance is directly proportional to the concentration. Meaning the higher the concentration, the more light absorbed, right? The lower the concentration, the lower the light that will be absorbed. Do you understand that? That is Beer's law. Now, Lambert's law. Lambert's law states that the absorbance of a light absorbing material is directly proportional to the path length. If you don't call it path length, you call it thickness of the solution. So it's directly proportional of the path length and independent of the what? Intensity of the light. Let me explain what Lambert's law is talking about. If you have this solution, give me shades of blue. Shades of blue. Let's say we have navy blue. Navy blue. And we have sky blue. You notice that this one is thicker than this one, right? The color, this one is thicker than this one. Which one, looking at it, if you have a solution that is thick like this and one that is light like this, which one do you think will absorb light more? The one that is what? The one that is thick will absorb more light. Will absorb more light. So Lambert's law is stating that the thicker the solution, the more light it will absorb, right? Now you look at it now, if you have a solution that is thick, you pass light through it, you will notice that the amount of light that will come out to be low because it will absorb more light. But if you have something like water that is colorless and you pass light through it, the one that is passing out will be more. Is it not? So Lambert's law says that the amount of light, the absorbance of a light absorbing material is directly proportional to the thickness of the material. The thickness, that is how thick the color is. And I said it's also called the what? The path length, right? The path length. And it's independent of the intensity of the light. Whether the light is too bright, not too bright, it's none of our business. Do we get that? So Beer's law is talking about absorbance is directly proportional to concentration, right? Lambert's law is talking about absorbance is directly proportional to the what? Path length or thickness. Now, if you combine these two laws together, you have your Beer-Lambert'S law. You have your Beer-Lambert'S law. And Beer-Lambert'S law states that now if you are combining these two, you agree that both of them are talking about absorbance, right? But this one is talking about the concentration. And this one is talking about the path length or thickness. So if you are combining the two, you agree with me that the law which states that the absorbance of a light absorbing material is directly proportional to the what? Concentration and the what? Path length. That's Beer-Lambert'S law. We're actually combining the two. that the absorbance of a light absorbing material is directly proportional to the concentration of the solute in the solution and the thickness or the path length. Now, if you look at this, if we want to, please take note because I want to do something here. If you want to remove this proportionality sign, you introduce a constant, right? And the constant here, you use epsilon. A here represents what? Absorbance, right? This formula here is for the Beer-Lambert's law. Epsilon here, sorry, C, let's take C first. C represents what? Concentration of the solute in the solution. L here represents what? Path length or what? Or thickness. Epsilon here represents what? Absorptivity. So this is molar absorptivity constant. The epsilon. Because this topic we are looking at absorption metric. So this epsilon here represents molar absorptivity. So this is Beer-Lambert's law. Now, if you want to restate Beer-Lambert's law, there's an alternative formula you can use. But now before I give you the alternative formula, now look at this. If you have something like this, this is the ray of light. If you have the ray of light and you have your material here that you want to test, now you agree with me that it is not all the light that you place on the substance that will be absorbed, right? Some will pass through the material and go out. Is it not? This light that you put on the material is called the what? Incident, right? Yeah. Incident light or incident ray. Incident ray is given as I naught. Then some of the light will be absorbed, right? While some will be emitted, is it not? This one is called the what? Okay, emitted, right? Or refracted. Emitted ray is given as I. Now, if you want to measure already, let's say you know the amount of light you incidented. I know the amount of light that is going out. If you want to measure the amount of light that is absorbed, what will you do? Thank you very much. Incident ray. If you want to measure the amount of light absorbed, it's just the incident minus the one that is emitted, right? Is it not? Let's say you let me make it physical. If you started with 20 units and 5 units is coming out here, you agree with me that how many units is absorbed? 15 units, right? What did we do? 20 minus 5. So this is this. So the amount of light absorbed, the absorbance, is equal to incident ray minus the emitted ray. Now, if we want to restate the Lambert's formula, the Beer-Lambert's formula, remember we started with absorbance, right? And the absorbance now, to check the absorbance, we said the incident ray minus the what? Emitted ray, right? If we want to write it in logarithm form, it will be log, in logarithm minus will be what? Division, right? Log I naught over I, this is the emitted ray, is equal to epsilon CL. If you see this formula, is the same thing because now this is absorbance is equal to this. So if you can use this one, you can use this one also. They are talking about the same thing. So basically, this is the Beer-Lambert's law. Remember that Beer's law relates absorbance to what? Concentration, right? While Lambert's law relates absorbance to what? Path length. Any question?